Swayam Prabha. Digital India. Educated India.
Welcome to this lecture on transition metal organometallic chemistry from principles to applications. We have been discussing a very important class of transition metal organometallic compound, that is the transition metal carbene complexes over last few lectures, and in that we have developed this concept of transition metal carbene complexes, particularly from the perspective of their synthesis, their classifications and their reactivity. So, these transition metal carbene complexes are extremely important from application point of view, because they are important intermediates in many catalytic cycles, and from that perspective understanding them is of crucial importance for designing better and more efficient catalysis. Now, with that perspective in mind, we have looked into the synthesis as well as classification of these transition metal carbene complexes. In the last lecture, we have also looked into the characterization methods that are often used for characterizing this kind of complexes. That includes various spectroscopic techniques like carbon, proton, NMR, as well as IR, and also by single crystal X-ray diffraction studies. We have also discussed about the reactivities of these kind of transition metal carbene complexes. In the last lecture, we had seen that Fischer carbene complexes are partially positive at the carbonic carbon. As a result, they undergo reactions with nucleophiles. We have also seen that that because of this reaction of the nucleophile, if any carbanion gets generated adjacent to the Fischer carbene center, that carbanion is stabilized by the carbonic moiety, and that was established by isotope leveling experiment, which we had discussed in the previous lecture. Now, in this lecture we are going to study the reactivity of transition metal carbene complexes in bit more detail in terms of various reactivity that they exhibit, and also we are going to try and draw a parallel between the Fischer carbene and the Strock carbene complexes in terms of complementary reactivity that they exhibit, and try to understand the reasons behind such difference in their reactivity. Now, it may seem that this carbene moiety bound to a transition metal should be a effective reagent for to be transferred on to other molecules. So, they can be thought of as very good carbene transfer reagents, but what it turns out that transition metal carbene complexes are poor source of free carbene. And this is illustrated by the example given below. So, for example, this Cp Fe iron R2 CH2 O CH3 when treated with CF3 CO2H eliminates methanol, which gets protonated OH to give this iron carbene complex and that carbonic moiety bound to this iron can be thought of as a carbene transfer agent, and such carbene transfer reactions are not very common, but observed in few cases where transition metal carbene moiety can transfer its carbonic moiety onto another substrate or another transition metal. So, we are going to look at some of the examples which had shown the transition metal carbene complexes as carbene transfer agents, and the first example of this chemistry was shown by Brookhart way back in 1987, when he treated this iron complex with carbene trapping reagent in terms of an olefin, and he was successful in making cyclopropane ether of the type shown, which clearly demonstrates that the CH2 moiety of the carbene center has added onto this olefinic double bond of the olefin substrate, resulting in cyclopropanation. So, this was one of the few examples or few examples of carbene transfer reactions carbene transfer reactions which transition metal carbene complexes exhibit. I must say that these reactions are not very common though, and only in certain specific cases these carbene transfer chemistries seem to work very nicely. Otherwise, these transition metal carbenes are poor source of free carbenes, as these carbenes are stabilized only when they are bonded to transition metal. We are going to look at another example of such carbene transfer reaction, where carbene bound to a transition metal in a transition metal carbene complex is effectively transferred onto organic substrate to give a value added product, as can be seen in the next example. For example, in this chromium carbene complex, CO4 Cr OMe pH bound to phenyl propyl methyl. So, this phosphorus center is a chiral phosphorus, and when that reacts with diethyl fumarate, at 40 degrees centigrade, and for 6 hours, this cyclopropyl ring is formed having OMe pH O CO2 ET CO2 ET. So, now one may argue that this cyclopropane ring is formed from free carbenes, but that is not true, as this product formed also is chiral, and hence it gives optically active cyclopropane ring, and since this optically active cyclopropane ring comes from chiral chromium Cr2 carbene complex, so one may argue that participation of free carbene is unlikely. Free carbene does not occur. So, because had free carbene participated, then this optically active cyclopropane ring would not have formed, because the free carbene could add to this diethyl fumarate from both sides, resulting in racemic mixture of the cyclopropane ring. Now, this shows that indeed this chromium carbene complex is acting as a carbene transfer agent, because there is a transfer of chirality from the complex onto the substrate along with the transfer of carbene. So, this also is one of the few rare examples where transition metal carbene complexes have been used for carbene transfer reactions onto substrates. This has been done in an asymmetric fashion to make cyclopropane ring, as well as in a chiral way, achiral way, which was discussed with the for the iron complex. So, there is chiral not only the chirality transfer, but also carbene transfer as carried out by this chromium complex. Now, we are going to look at another very interesting reactivity of carbene complexes, which is used for synthesis of benzynylation reactions. That means that aromatic rings have been synthesized effectively by the reactions of transition metal carbene complexes, where they serve as carbene transfer agent, which sort of gives further value added chemicals, and this has been used in synthesis of natural products. So, this is a very interesting reaction called benzynylation reaction. And this is given by the reaction of this carbene complex reacting with alkyne at 50 degrees centigrades, which eliminates carbon monoxide to give these naphthals OH, R1, R2, OMA, and chromium carbonyl complexes. So, this reaction of carbene with alkyne gave substituted naphthals pi bonded to transition metal. So, this is a very interesting chemistry where one can see that these aromatic rings are constructed using carbene complexes, where carbene complexes are used in a stoichiometric fashion, not in a catalytic fashion, and this reaction is popularly called as benzylation reactions, where benzene ring is constructed by the reaction of carbene with acetylenes, the way it has been shown over here. Now, this is a very important application of transition metal carbene complexes, and this was discovered by Dodds way back in 1975, and this popularly is also called Dodds reaction. This particular reaction is popularly named as Dodds reaction as well. Okay. Now, we have seen various reactivity of transition metal carbene complexes. We had seen that the Fischer one undergoing nucleophilic additions that we had seen. We have also seen the Fischer one stabilizing carbon ions through isotope experiments. In addition to that, in today's lecture, we have seen that these carbene complexes can undergo carbene transfer reactions, though these reactions are not too common, but we had seen it occur for two examples where carbene has been transferred onto olefinic substrate, both in a achiral as well as chiral fashion depending on the catalyst which were used. We have also seen that the carbenes can be used for making aromatic rings using reactions with alkyne, and that we had seen in that this reaction produced substituted naphthals which can be used for synthesis of various natural products. We are going to now discuss another very interesting reaction of carbenes which are parallel to Wittig reaction with ylides. So, carbene complexes undergo Wittig with ylides, and this is illustrated by the example. So, your tungsten pentacarbonyl, C phenyl plus this PH3P double bond CH2 giving CO5 tungsten PH3 plus CH2 CPH pH. So, this we see similar to that of Wittig reaction, where this CH2 moiety has added to this carbonic diphenyl carbene moiety to give this olefin, which is CpH2 and another side CH2 which comes from this. Now, this is very similar to the Wittig reaction which we are aware of. For example, instead of the carbene, one can think of ketone reacting with the same reagent giving phosphine oxide plus this olefin. So, exactly similar to that of the Wittig reagent. Now, these similarity of these reactions can be rationalized based on isolable reactions can be rationalized based on isolable analogy For example, for tungsten pentacarbonyl is isolable with iron tetracarbonyl. Now, these can be explained as such. For example, tungsten pentacarbonyl is D6 Ml5. So, that means it is 16 valence electron species, and FeCO4 is D8 Ml4. This also is a 16 valence electron species, and as far as the organic quantities are concerned, that this is isolable with CH2, which also is isolable with oxygen, both of which has 6 V. So, these two are organic molecules which are isoelectronic and isolable, and these two are transition metal compounds which are species which are isolable and with each other. Okay. Now, because of the isolability principles, their reactivity also can be explained. So, Wittig reaction is a very important reaction which is exhibited by carbenes, and this is analogous to that of the Wittig reaction that is used with ketones, and both of these Wittig reactions results in the formation of olefins, as is the case observed for the Wittig reactions of organic molecules. We are going to now sort of take a look at some of the examples of Wittig reactions, particularly with Schrock type of carbene. So, Schrock carbene are nucleophilic in nature, and reacts with electrophile So, let us take a look at this particular complex tantalum CME3. Now, as I said that their reaction with electrophile arises from the fact that this carbene is negatively charged because of carbene is negatively charged because of this carbon being more electronegative than tantalum, and this carbon is engaged in two types of covalent interaction with the tantalum, the carbon to metal sigma bond and the metal to carbon pi bonds, and these are simple covalent bond in which a triplet carbene carbene is seen interact with tantalum, as a result of which because of higher electronegativity of the carbon, this carbonic center is negatively charged, and because of which this carbonic center reacts with electrophiles. So, for example, the reaction of these with let us say a carbonyl compound gives the following product. Me3 CH2 whole 3 tantalum oxo plus C8 Me3 double bond R H. So, what one sees that this moiety is attached over here and this moiety is attached over here. So, now this gives in the olefin product as a result similar to that of a Wittig reagent, where a Wittig reagent reacts with a carbonyl compound to give olefin. So, this is a very interesting application of transition metal carbene complexes. So, with this I would like to draw the conclusion about today's lectures, which had mainly been on following. We have started the lecture by looking into the reactivity of transition metal carbene complexes. In this lecture, we have looked into the nucleophilic addition reactions which are typical of Fischer carbene. The source of such reactions, we have looked into reasons as to why Fischer carbene undergoes nucleophilic addition reactions. We have also seen in the beginning of this lecture as to how the Fischer carbene complexes can stabilize the formation of carbanion upon deprotonation reaction, and this was established using isotope leveling studies experiment. We have also subsequently looked into these applications of transition metal carbene complexes, particularly with regard to carbene transfer reactions. Though the free formation of free carbenes from transition metal carbene complexes are very rare in nature, however, there exist examples where free transition metal carbenes has been used as carbene transfer agents, where they transfer their carbonic moiety onto olefins, and this has been achieved both in a chiral as well as chiral fashion depending on the catalyst which were used. We have also subsequently looked at parallel reactions where carbenic transition metal carbene complexes has a similar reactivity to that of the elites or of the Wittig reaction. So, this one great applications of transition metal carbene complexes is the Wittig type reactions which these complexes organometallic complexes display. We have also looked at another applications where aromatic rings, benzonylation reaction where aromatic rings are formed from the reaction of transition metal carbene complexes with alkyne. So, with this I conclude today's lecture. We are going to take up this reactivity in bit more detail in the subsequent lecture, where we are going to look at the Wittig reactions of transition metal carbene complexes and draw a parallel between them with that of the organic reactions that we are aware of. In more details, and also few more reactivity of transition metal carbene complexes. So, with that I thank you for being with me in this lecture and look forward to being with you in the next lecture. Till then, goodbye and thank you.